All right. This geometry puzzle is extremely satisfying once everything clicks together. We have a perfect square, A, B, C, D. And inside the square is this blue shaded quadrilateral. Our mission? Find the exact area of the entire blue region. Let's start collecting the clues. The top boundary of the blue shape is made from two line segments. EF has length 10, and FC has length 40. But here's the really important detail. Angle EFC is a perfect 90 degrees. That right angle is going to unlock the entire puzzle. Now remember, because the outer shape is a square, the corners at A and B are also 90 degrees. So let's zoom in on point F. The top edge of the square is a straight line, meaning the angles across it total 180 degrees. Since the middle angle at F is 90 degrees, the two remaining little angles must add up to another 90 degrees. Let's name them. We'll call the left angle alpha and the right angle beta. Now, look carefully at the white triangle on the right, triangle FBC. It already has a 90-degree angle at B, and the top angle is beta. That forces the remaining angle to be alpha. And now something beautiful happens. The two outer white triangles, triangle AEF and triangle FBC, have exactly the same three angles, which means they are similar triangles. And once triangles are similar, their side lengths must follow the same ratio. Let's call the side length of the big square X, and let's call the small top segment AF Y. Now we set up a proportion. The big triangle has side length X and hypotenuse 40. The smaller triangle has side length Y and hypotenuse 10. So we get X over 40 equals Y over 10. Cross multiply, and suddenly we discover something huge. X equals 4Y. The side length of the square is exactly 4 times that smaller segment. Now look at the entire top side of the square. Its total length is X, which means it equals 4Y. But the left portion, AF, is only 1Y. So the remaining piece, FB, must be 3Y. And now we are perfectly set up for the Pythagorean theorem. Look at right triangle FBC. Its legs are 3Y and 4Y, and its hypotenuse is 40. So 3y squared plus 4y squared equals 40 squared. That becomes 9y squared plus 16y squared equals 1600. Combine them, 25y squared equals 1600. Divide by 25, and we get y squared equals 64. So y equals 8. And if y is 8, then x, which equals 4y, must equal 32. So the side length of the square is exactly 32 units. Now comes the final step, finding the area of the blue region. And the cleanest way to do it is by splitting the blue shape into two right triangles, triangle EFC on top and triangle CDE on the bottom. First, triangle EFC. Since it's a right triangle, its area is simply 1/2 times base times height. So 1/2 times 10 times 40, which gives us exactly 200. Now for the lower triangle, CDE. Its base is the bottom side of the square, 32. But we still need its height, ED. Look back at the tiny white triangle in the upper left corner. Its hypotenuse is 10, and one leg is 8. Using the Pythagorean theorem, 8 squared plus height squared equals 10 squared. So 64 plus height squared equals 100, which means the height squared is 36. So the height is 6. That means the little top left vertical piece is 6 units tall. Since the entire square has height 32, ED must equal 32 minus 6, which is 26. Now compute the area of triangle CDE. 1/2 times 32 times 26, which equals 416. And finally, we add the two blue pieces together. 200 plus 416 equals exactly 616 square units. Such a beautiful puzzle. Everything looks messy at first until those similar triangles suddenly reveal the hidden structure. Let me know in the comments if you solved it a different way, and I'll see you guys in the next video.